Welcome, welcome everyone. I am Subhashish Chandra and I welcome you to our series Cosmos. In this series, we have looked into the Sun and its 8 planets in the previous 3 chapters. In today's chapter, we are going to look into the dwarfs, that is, Pluto, dwarf planets, asteroids, Kuiper belt, and Oort cloud. Let's start with Pluto, or Yum as it's known in India. Pluto is a complex and mysterious world with mountains, valleys, plains, craters, and maybe glaciers. Pluto is named after the Roman deity Pluto, the god of the underworld, and it was discovered by Clyde Tombaugh on 18th February 1930. Incidentally, it was named by a 11-year girl called Venetia Burney. It has a radius of 1188 kilometers, which makes it even smaller than our moon. Its mass is about 1.3 into 10 to the power of 22 kilograms, and it has a very oval shaped orbit. Pluto's highly eccentric oval shaped orbit brings it inside Neptune's orbit for a 20-year period every 248 Earth years. Despite Pluto's orbit appearing to cross that of Neptune, when viewed from directly above, the two objects' orbits are aligned so that they can never collide or even approach closely. It takes about 248 Earth years to revolve around the Sun. It rotates on its axis in 153 hours. 283 minutes are required for sunlight to reach Pluto. The surface is mostly nitrogen ice. It has an internal structure of a silicate core enveloped by liquid water ocean and a crust of water ice. The temperatures are too low as it is very far away from Sun, and the atmosphere is a tenuous one comprising of nitrogen and methane chiefly. It has an axis of rotation of 122.5 degrees with respect to the plane of orbit. Life is non-existent on Pluto. There are 5 moons of Pluto, the largest of which is Charon. Charon is about half the size of Pluto itself, making it the largest satellite relative to the planet it orbits in our solar system. Pluto and Charon are often referred to as a double planet. The other moons are Styx, Nix, Kerberos, and Hydra. Now, from 1992, many icy bodies were being discovered orbiting in the same solar region as Pluto. So, on 24th August 2006, International Astronomical Union decided to define the term planet as a celestial body which is in orbit around the Sun, has sufficient mass for its self gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium, that is a nearly round shape, and it has cleared the neighborhood around its orbit. Now, Pluto scored on the first 2 counts but failed on the last count, and it was demoted from being a planet. Then a new term was defined which will define Pluto forever, and the term was a dwarf planet. But there was a condition that it should not be a satellite. Now, where do we find these dwarf planets? Pluto is one, but where are the others? So, the first destination where we will find our dwarf planets is the asteroid belt. The asteroid belt is named after the Greek word asteroids, which means star-like, and this name was given by William Herschel. Now, what are these asteroids? The asteroids are millions of small rocky bodies situated in between the orbits of Mars and Jupiter, and these bodies also orbit around the Sun. The width of the asteroid belt is about 1 AU. 1 AU is the distance between the Earth and the Sun. Now, even though the asteroids are formed of millions of small rocky bodies, their total mass is less than that of the mass of the moon. Now the question arises, what are these bodies actually? So, during the first few million years of the solar system's history, an accretion process of sticky collisions caused the clumping of small particles, which gradually increased in size. Once the clumps reached sufficient mass, they could draw in other bodies through gravitational attraction and become planetesimals. This gravitational accretion led to the formation of the planets. These bodies could not form the planet because of the extreme gravitational pull of the planet Jupiter. So, astronomers believe that this belt is basically a failed planet. This asteroid belt is the source of most of the meteors and meteorites that come to our Earth. There are other types of asteroids as well. We will look into them in a further video. The next destination where we find the dwarf planets is the Kuiper belt. The Kuiper belt is one of the largest structures in our solar system and is shaped like a puffed up disk or a donut. It is named after Gerard Kuiper, who published a scientific paper in 1951 that speculated about objects beyond Pluto. It is comprised of millions of small icy bodies beyond the orbit of the planet Neptune, and hence these bodies are also called as the Kuiper belt objects KBOs or trans-Neptunian objects TNOs. If dwarf planets exist in this belt, they are specifically called as Plutoids. The width of this Kuiper belt is about 20 AU. The planet Neptune is at 30 AU from Sun, so the edge of the Kuiper belt is at about 50 AU from Sun. Overlapping the outer edge of the main part of the Kuiper belt is a second region called the scattered disk, which continues outward to nearly 1000 AU with some bodies on orbits that go even farther beyond. The mass of the entire Kuiper belt is less than 10% of the mass of Earth. It is the source of the short period comets, the comets that have time period less than 200 years. Let's look into our dwarf planets. The first dwarf planet is Ceres. It was first discovered by Giuseppe Piazzi on 1st January 1801 and is named after the Roman goddess of corn and harvest. It is a small ball having a radius of 476 kilometers and can be found in the main asteroid belt. The day in Ceres is about of 9 hours, that is, it rotates on its axis in 9 hours. The most interesting thing about Ceres is that water is available on this planet, and the astronomers are trying to find out more about this particular dwarf planet. The next dwarf planet is Eris, and it was discovered by Brown, Trujillo and Rabinowitz on 21st October 2003. Brown has been referred to by himself and by others as the man who killed Pluto. He even wrote a book on this topic. Eris is named after the Greek goddess of discord and strife. It is aptly named so because it is the discovery of this planet which put the position of Pluto as a planet into question. It has a radius of about 1163 kilometers, which is nearly about the same size as Pluto. It is though believed that Eris has more mass than Pluto. It is found in the Kuiper belt and the day is of 25.9 hours. It has one moon, Dysnomia. The next planet, or rather a dwarf planet, is Makemake. It was also discovered by Brown, Trujillo and Rabinowitz on 31st March 2005. It is named after the Rapa Nui god of fertility. Rapa Nui is a tribe found on the Easter Islands. It has a radius of about 715 kilometers and is also present in the Kuiper belt. The day is of 22 and a half hours and it has a moon which is called Mk2. The last dwarf planet is the most interesting one. Its name is Hama Maya, and International Astronomical Union says that it was discovered in Sierra Nevada Observatory in Spain in 2003. Even though Brown also claims that he and his team discovered it independently in 2004, whereas in 2003 it was discovered by Ortiz and its team. International Astronomical Union has not acknowledged any discoverer. It is named after the Hawaiian goddess of fertility and is 620 kilometers in radius. It is also present in the Kuiper belt. The most interesting thing is its day, that is, it rotates on its axis in 4 hours. That is the fastest known for any celestial body in the entire solar system. This fast rotation has caused Hama Maya to have a rugby ball like structure. It has two moons. The inner moon is called Namaka and the outer moon is called Hayaka. These are the daughters of the goddess Hama Maya. It is also the only dwarf planet to have rings. We have now arrived at the outskirts of the solar system. Let us see what is in the outskirts of the solar system. The outskirt of the solar system is the Oort Cloud. The Oort Cloud lies far beyond Pluto and the most distant edges of the Kuiper belt. While the planets of our solar system orbit in a flat plane, the Oort Cloud is believed to be a giant spherical shell surrounding the Sun, planets, and the Kuiper belt objects. It extends from about 2000 AU to 100,000 AU. It is named after the Dutch astronomer Jan Oort, who was the first to propose this region. There are billions or even trillions of icy bodies in this region, and this region is the source of the long period comets. We have now arrived at the edge of our solar system. In the next chapter, we will be looking into the travelers, that is, the celestial bodies which travel from these outskirts towards Earth. Till then, stay healthy, stay safe. Thank you.